Hi, I'm Ramy Mizrachi,
I'm Dylan Lee.
And I'm Leon Bewersdorff.
and this is our presentation, an analysis of exoplanet WASP-50b with Exotic. We hope you enjoy. It is important to note, before we get started, the purpose of regularly updating exoplanets ephemeris. It is important to regularly remeasure exoplanets ephemeris as it reduces uncertainty accumulated over time and it allows for less expensive future imaging. We will see the effects of this accumulated error later in our presentation when we take a look at the O-C plot we made for this study.
Here you can see a two-dimensional layout of WASP-50, the host star of the exoplanet we're studying, and other stars near it. This star chart was created by the American Association of Variable Star Observers Variable Star Plotter, and it shows us which comparison stars are viable and near WASP-50. WASP-50 is located at the center with the plus sign, and the comparison stars which we were suggested have numbers next to them, 116 and 120.
This is one of the light curves that our study produced. A light curve is a measure of the amount of light emitted by a star and plotted against time. The light that we see emitted from the star WASP-50 diminishes as the planet passes or transits in front of it. It was taken with the baseline time towards the beginning to standardize the brightness, then shows a dip as the planet transits, and then another baseline at the end for standardization purposes.
This is our O-C plot. O-C stands for observed minus calculated, and the aim of it is to see the difference between the exact middle of the transit, the mid-time, and what it was calculated to be. On the y-axis, we have the deviation from the calculated mid-time in minutes, and on the x-axis, we have the epoch, so the amount of times that the exoplanet has orbited its host star. The purpose of these plots is to find a trend in the transits, as it allows us to spot an uncertainty in the calculations, for example, for the orbital period or for the exact middle of the transit. This ties back to the idea of measuring the uncertainty and showing how it accumulates over time. This is shown by the O-C. The mid-transit times here are trending down and to the right, which means that the mid-transit is occurring before we expect it to, and increasingly so.
This is an O-C plot that we took from ETD, the Exoplanet Transit Database. We have this O-C plot to compare against our O-C plot that we made for our study. This allows us to confirm our O-C plot against existing plots to verify and compare the trend that we found in our light curves.
These two graphs here are the light curve and seeing quality for the October 27, 2013 transit of WASP-50b. The purple line on the left graph gives an indication of the weather during the imaging process of the transit. It ranks the weather quality from 0 to 100, 100 being perfect quality, no cloud cover, very dark, and 0 is completely overcast. When the transit starts out, the weather is around 83 and keeps increasing until the end of the transit. The weather quality goes down and it affects our images taking during the period of bad weather by creating very large error bars. When we look at the corresponding light curve on the right, we can see that it is in fact a light curve. We have a flat start before the transit, the baseline, a dip during the transit, and then we can see that the images on the light curve go completely haywire. This is correlated to the bad seeing quality. So what we do in this case is recalculate the light curve, but remove the bad images so that we get a usable light curve. Our acknowledgements go out to the Society for Astronomical Sciences, the Micro Observatory Network, the NASA Exoplanet Watch, and the Institute for Student Astronomical Research for all of their help with making this study possible. Thanks for watching, and we hope you enjoyed.